today we are going to look at interfaces and abstract classes in Java. So when we look interface is an very important concept when it comes to the inheritance in Java. So interface represents various behaviors of a particular type, which could be of a particular type, and they could be maintained as an abstract. And whenever another class implements this particular type, then they have to provide their own implementation for those various behaviors so that it could be applied accordingly. So this is normally an example of, let us say, an animal. An animal can be of anything. So a dog, a sheep, a goat, a crocodile, and all these are animals. But when we come to the underlying concrete classification, dogs, cats, and rabbits, all these are a separate class of animals of its own. Okay, so in that way, we define interface at the higher abstraction level, and there will be concrete implementations of these interfaces. So, with the introduction of Java 8, interfaces before Java 8 used to have abstract methods. However, with Java 8, default implementations of the methods and static methods are introduced in Java. With that, even though we can either keep the methods abstract or we can give a default implementation to those interfaces, and those interfaces will be uh, when extended or implemented by the subsequent concrete classes. The concrete class can utilize the parent implementation, or they can go with an concrete implementation of its own. So in this way, there is an extended features added in interfaces. So let us look at its implications and implementation. Interface. Sorry, I am going to show you as part of this as part of JShell. So in JShell, let us say interface. Mm, I okay. So by default, all the methods in an interface are public. We need not exclusively define them as public. So I'm going to give an abstract method. Abstract method. So for this method, the implementation should be given by the concrete class. So I want to give a default implementation. Okay. Okay. Next, I'm going to create a static method in it. Sorry. I'll extend it a little. And this is interface I is created. Now we will create a concrete class. Okay. So class concrete since this implements I, we have to implement this is an abstract method implementation. So why this is an abstract method, abstract method. Okay. Okay. So this is it. This is it. So concrete is the class. Now let us say that c equal to concrete. Now the concrete method is created. Now let us see what is the visibility of this concrete class. Okay, so if we look at, so let us say, first let us look at the default implementation, whether there is an access. So here if you see, this is an abstract method and this method has default implementation. Okay, there are two methods that are visible. Okay, so if we see here, when we invoke that this method has default implementation, since we didn't override this method in the concrete class, okay, so it gets derived or imported from the parent class, which in here it's an interface. So since it gets inherited from an interface, so the implementation of the interface is used and default implementation at interface I is displayed. Now similarly, let us say uh, we have implemented this. This is an abstract method in the concrete class. So if we hit that, so this is a concrete implementation for an abstract method has been displayed. Okay, so in when we use an interface, we can use multiple interfaces. We can implement multiple interfaces in a concrete class. Let us say interface I2. Okay. Mm, I2. Okay. Now I2. Okay. And since we do not have a place here, I'll just give the implementation here. Okay. This is the concrete class has been replaced. Let us just create c equal to new concrete. concrete. Okay, so c dot. If we see, we can see that there are three methods. So this is an abstract method. Okay, this method has default implementation. This is a method in I2. So if we see here, a method that is implemented in interface I2, since we are implementing two interfaces, it gets extended. So it gets visible in the child implementation. Okay. Method. So this is a concrete implementation, correct? Okay. Now we might even get a few queries with the introduction of the interface default methods and the static methods in interfaces. We might even get a question in such a scenario, what is the relevance of abstract classes, right? Because anyways, interfaces provide their own implementation and default implementation which could be utilized by the subsequent concrete classes. So are abstract classes still relevant? Okay, so we will try to see in which way abstract classes are relevant. Let us create an abstract class. Okay, abstract class. Abstract. Okay, now I have to create an abstract method. So as we all know, in the abstract class we can either create we can create variables as well, right? So yeah. Okay, just to avoid the getter method for the name, I have given it as protected. Okay, now I have to give an abstract implementation. Okay, okay. Let us make it private. Okay, abstract class is created. Now let us go ahead and here we will use an yeah, we will create a class extends abstract. Okay, okay. Now here we will use an parameterized constructor because the abstract class at the higher level is expecting a parameter. It has a parameterized constructor, and we will use the super keyword. Super keyword basically refers to the parent class whenever we want to utilize the implementation, default implementation or some implementation that is provided in the parent class. We want to utilize that, execute that, and upon that if we have to implement any more changes. Okay, so normally we go with the super keyword. So here I want to utilize the parent constructor, so I am calling the super. Okay, that is done, and I do not want to give anything else. So uh, I'm sorry, I think I need to change the abstract implementation first. This should be protected because if I have to get the name in the subsequent class, then I need it. Okay, class abstract implementation extends abstract. Okay, public abstract implementation of string name super of name. Okay, that's it. And So I have given a concrete implementation of the display my name. So the class is created. Now we will create an object out of it. Okay. Now now if you observe in the abstract implementation, I do not have a separate variable named name. Okay, and in my parent class I have an abstract. I have a variable which is of which whose name is name. Okay, variable name is name, but which is protected. So since it is protected, okay, as per the visibility rules, since abstract implementation is extending abstract, the string name also will be visible in the subsequent abstract implementation class. So let us see. Yeah, so if we see here, the name is visible in the in the child class. Okay, now so in this way, abstract classes work in this way. Okay. Now, if at all we do not implement any methods from the abstract class, then the subsequent class also becomes an abstract class. Similarly, from the interface, if we do not implement any methods, and if those methods do not have any implementation in the parent class, okay, then those classes become abstract classes. Okay. So for example, in our example, let us go and see. Okay, so we have interface I2, right, which has an abstract method, so without any implementation. So class abstract um, abstract demo implements I2. Okay, if you see here, abstract demo is not abstract and does not override abstract method in I2. So either I need to mention the class as abstract, or it doesn't allow, or I need to provide the implementation. Okay. So let us give some method in I2. Let me check what is that method in I2. Okay, it's a void. Okay, public void. Okay. Okay. Replace the abstract demo. So now, okay, dot. If you see, so the implementation has come in. So we might it might from the exterior view we might feel that with the introduction of the default methods in the interface, abstract classes become redundant, but that is not the case. So interfaces provides a default implementation, and if at all in the child class we do not want to utilize that implementation, we will write a new implementation on our own in the concrete classes. However, if at all we want to utilize the default implementation in the in the interface, and upon that if we have to write something, implement something, okay, then there is no provisions as of now. There is no provision in the interfaces, so we have to either use the default or we have to write our own. Okay, so we cannot reuse the code in that manner. Okay, because super keyword doesn't work in interfaces. Okay. Whereas coming to the abstract classes, in the scenarios where we have an parent implementation in the abstract class and we want to utilize that code, and upon that, if we have to write our own implementations, then we can use the super keyword for invoking the parent class methods or constructors. Okay, and upon that, we will write our own implementations. Okay, so this is how we can reuse the code. So in the interfaces, though it is more flexible, it doesn't has that flexibility of providing code usage, so we have to duplicate that code. Whereas coming to the abstract classes, we need not duplicate the code. We can use the super keyword to use the parent to use the implementation of the parent class. So let us see it as a demo in abstract class. For example, we already demoed it using the super keyword in the constructor. Now let us do the same in um, as a method. Okay, abstract class. Okay, okay, abstract class. Sorry. Okay, public string. This is a implementation. Okay, okay. Now we have to change the abstract implementation. Let us change the abstract implementation. Okay, now here public string. This this is a concrete implementation. Okay, so here I would use the parent method. Okay, now for this, since it returns something, I'm going to print it. Okay, now for this method, I'm going to return saying this is an implementation from concrete class. Okay, oh sorry. Okay, so now where abstract abstract detection of Windows. Okay, now we will try to display this. So apps demo dot display name. If you see, this is my name, Windows has displayed. Now I would like to use, first we will look at the super keyword implementation. So this is a concrete implementation. So if we see here, there are two statement. There is a statement that is displayed and another returned as string. So the first is, this is a concrete implementation from abstract class. So we have created a concrete implementation of a method, okay, in the abstract class. Now if you see here, so this is a concrete implementation. This is a concrete implementation from abstract class. Now similarly in the abstract implementation, okay, we have used the super keyword to invoke the parent implementation, and then upon that we are returning what we have written the code, and we are returning the string whatever we want to return. So that is displayed. So in this way we can implement the code reusability, which will reduce the number of lines of code that we need to implement. So in this way, both interfaces are important and abstract classes are also important. And abstract classes are important in its own way. For example, in the strategy design pattern, we normally use abstract classes extensively. Okay, and there are a few cases, play scenarios where we'll use interfaces extensively. So in Java, to implement the code reusability and improve the quality of service parameters. So both of them have their own importance. So both abstract classes and interfaces are important, and in this way, it even reduces the amount of code that we need to write, and the amount of code maintainability and everything can be handled. Okay. So this is about abstract class and interfaces. So thank you.